Today we are starting with linear functions. The key feature of a linear function is that it has a constant gradient, as in it keeps going down or upwards at a constant rate. The amount that it runs is the same amount that it rises every single step. The gradient can be expressed in many different ways, but the general formula that you're going to use is y2 minus y1 over x2 minus x1, which is your rise. So what is the difference between your y values over your run, the difference between your x values. Some key points for parallel lines is that the gradients are the same, and for perpendicular lines, which means they intersect at 90 degrees, is that when you multiply the two gradients, it will always give you -1. Or another way that I like to think about it is that the normal gradient, so that's the gradient of the perpendicular line, is equal to -1 on the gradient of the original line. Here are another few points. So this one, point 1 is the equation of a linear function. So that's y equals mx plus c. This is usually the function style that I'm going to be using. But you can, of course, use this formula as well. Y minus y1 equals m, x minus x1. And that's usually used to be able to find the equation of a function. However, I just prefer to use y equals mx plus c. In order to sketch, it is the easiest function because all you need to do is find the x-intercept by making y equal to 0 and then find the y-intercept by making x equal to 0. As we initially mentioned already, parallel lines means that they have the same gradient. Perpendicular lines has this formula. And this is a formula that you may or may not remember from year 11. But that's that tan of any angle is equal to the gradient. So a very popular one that we will use quite often is that tan of a line that makes a 45-degree angle will have a gradient of 1 because tan of 45 is equal to 1. Let's go ahead and apply some of these ideas. So example 1, consider the line L, where L is equal to this function. First thing they want us to do is to sketch the line. And as we said earlier, the two things that we need are the x-intercept and the y-intercept. In order to find the x-intercept, what we want to do is make y equal to 0. So we'll just go ahead and do that. That'll be 2x is equal to 12, therefore x is equal to 6. So my x-intercept is 6 and 0. Likewise, I'm going to find the y-intercept by making x equal to 0. So that'll be 2 times 0 plus 3y equals 12. That'll be 3y equals 12, divide both sides by 3, so y will be equal to 4. So my y-intercept is 0 and 4. And just like that, I can sketch that onto a line. So we will have 6, 0, 0, 4. Make sure you label your axes correctly as well. And we can draw a straight line through that, even though mine's not quite through it. We'll try that one more time. That looks a bit better. So just like that. So part B says calculate the gradient of the line. Now there are 3 different ways that you can do this. I am going to show you 3 different ways because I'd like you to know all of these different methods because they are useful in different situations. So the first method, and probably the one that you would probably go to most often, is just your general y2 minus y1 formula. Usually this is the one that I just immediately think of. So we do have 2 points as we found before, so that's as 6 and 0 and 0 and 4. So what we can do is label them as x1, y1, x2, y2, and we can then substitute that directly into the formula. So y2 minus y1 will be 4 minus 0, and x2 minus x1 will be 0 minus 6. So I'll get 4 on -6, which is the same as saying -2/3. So that's the first way that we can find the gradient. The second way that we can find the gradient is by putting it into the gradient intercept form. So that's your y equals mx plus c form. So at the moment, the equation that we have is 2x plus 3y is equal to 12. But if we rearrange it to get y by itself, it will be in that form and we'll be able to clearly see what the gradient is. So the first thing is I'm going to take the 2x over to the other side, and then I'm going to divide everything by 3. And so you can see that the value that's in front of x, which is the gradient, is -2/3. So that's the second way of completing this. Finally, the last way is that you can just calculate the rise over the run, and we can do this using the graph. So I'm not sure how the axes in my line joined. So the rise is pretty much how much my graph has gone up between 2 points. Since I've got 2 points here, I'm going to use these. In this case, it's gone down, so it's very important to know that it's going to be a negative, but it's gone down by 4 and it's gone across by 6. And so when I simplify this, once again, you can see that the gradient is negative 2/3. So any one of these works in all in situations. It's really up to you to figure out which one is the best one to use in the given situation that you have. For the next example, find the equation in the form of ax plus by plus c is equal to 0 for the line. And then it gives us a bit more information. So passing through the point 2, 3, and it's parallel to the equation y minus 3x plus 5 is equal to 0. So we're given several points here that it's really important. And I'm going to highlight this one firstly. It's the specific form that it wants. For me personally, I always finish this part of the equation, and because I'm in a rush, I move on and I completely forget about what form they want us to put it in. So that's maybe the number of decimal places, they want it the way that they want us to arrange it. So it's really important to highlight it and to remember that that's something that we need to do. What else do we know? We know that the line is going to pass through the point 2, 3. It's also going to be parallel to this particular equation over here. So what can we do here? Well, firstly, we know that parallel means that the two gradients need to be equal to each other. So how do we find this original equation, or the original gradient? Well, we can find the gradient from the original equation. So where I would start off is finding that gradient. So I want to put this equation into the form of y equals mx plus c, because that will give me that m1, that initial gradient, that's going to help me find m2. So that will be my second point. I'll be able to find that gradient of the new line. Then once I have the gradient of the new line, I can substitute a point that it goes through to be able to find c. And finally, I want to make sure I put it into the correct form that it's asked me to. So now I'm going to go ahead and follow these different points. So the first thing, as we said, what we're going to do is rearrange this equation here to put it into y equals mx plus c to find the gradient. So the original equation I have is y minus 3x plus 5 is equal to 0. I'm then going to take everything over to the other side. So this should be very easy. It's just 3x minus 5. So I can see that my original gradient is 3. And because the lines are parallel, that means that my second gradient is going to be 3 as well, because they're parallel. Now from there, I know that my equation so far is y equals 3x plus c, but I need to now find c. And so for my third point, what I'm going to do is I'm going to sub in the point 2 and 3 in order to find that c. So that's going to be 3 is equal to 3 times 2 plus c. 3 equals 6 plus c. Take the 6 over. That's going to give me negative 3. So the equation that I have is y equals 3x minus 3. And then, of course, we don't want to forget the final form that we want to put it in. And so all this form is telling me is that everything is on one side and it needs to equal 0. So all I'm going to do is I'm going to take the 3x and 3 to the other side. So that'll be y minus 3x plus 3 is equal to 0. And that's my final form. Part B is very similar. And likewise, we have to then present it in the same form. So that introductory part over here applies for this part as well. So that's why I've written it there, just so that I can remember to do that later on. So this time the line is going to be passing through the point -1 and 6. It's perpendicular, and it's going to be perpendicular to the line 2y plus 4x minus 10. And then, of course, don't forget that we have to put it in that specific form of ax plus by plus c is equal to 0. So it's going to be very similar to what we did before. We know that perpendicular lines have the property of n is equal to -1 on m. So what we need to do is be able to find that m gradient, and the way that we would do that is by looking at the original line. So just like before, I want to do this into the form of into the form of y equals mx plus c. Once I find that m, I can then use that to find the normal gradient, and then I would be able to substitute this point to find c, and finally I would put it in the appropriate form that it has asked for. So let's go ahead and do that. Step 1, what we're going to do is rearrange this equation. So we originally have 2y plus 4x is equal to -10. Now what I'm going to do is take the 4x over. So that'll be -4x minus 10, and then divide everything by 2. So we will end up with -2x minus 5, and that means my gradient is going to be -2. Now that I know that, I can find the normal gradient by substituting m into the equation. So that'll be -1 divided by -2, which is just 1/2. So far my equation is 1/2 x plus c. From there, I'm going to sub in my other point that I have, which is -1 and 6. I can substitute that into this equation. So that'll be a half -1 plus c. That y should be a 6. And that way I can solve for c. So first of all, that's going to be -1/2 plus c. When I take that over, that'll be 6 plus a half. 2 times 6 is 12 plus 1, so that'll be 13 on 2 is equal to c. So my equation is going to be a half x plus 13 on 2. And finally, I'm going to put it into the correct form. So as we did before, what we did was we took everything over to one side to make it equal to 0. So we will have a half minus, y minus a half x minus 13 on 2 is equal to 0. Now, technically this is correct, but there is something that we can do to make it look better. So as mathematicians, we really want to avoid negative signs, and we also want to avoid fractions. So as you can see, both of these are over 2. So what I want to do in this situation, if I multiply everything by 2, so both sides and every term, I will get rid of that fraction. So I'll end up with 2y, and then a half times 2 is just going to be 1. And then the same thing with 13 times 2 is going to be, 13 on 2 times 2 is just going to be 13. And that will be equal to 0. Now, you can, of course, have the option of multiplying it by -2, in which case everything would be the same, just the negative version of it. So it's up to you in whichever case you'd like to have that. Next, we've got example 3. So with example 3, it says calculate correct to one decimal place the angle made with the positive direction of the x-axis by the line that is passing through the points -3, -2, and 4 and 1. So you can see now we're using angles, and as soon as I'm seeing angles with linear equations with a line, I'm always thinking of this formula, tan theta is equal to the gradient over here. So calculate correct to one decimal place. I'm just going to highlight that again about that final form. The angle, so the angle has indicated that I'm going to be using this tan formula over here, made with the positive direction of the x-axis. This is just a matter of language. What that means is that when I have a particular line, it's with the positive angle of the x-axis, so we're talking about that part. You won't really need to focus on that until a little bit later on. And what we do know is that it passes through these 2 points here. So what we need to do is find that angle, and in order to find the angle, we know that we firstly need a gradient. So in order to find that angle, I need to figure out what m might be, and the way that we can find out that gradient is by the fact that I have 2 points already. So with 2 points, I can use the formula y2 minus y1 over x2 minus x1. I have 2 points, so -3, -2, and 4 and 1. And then I can label this x1, y1, x2, y2, and now it's just a matter of substitution. So that's 1 minus 2, and 4 minus 3. There should be a negative there. So it'll be 1 plus 2, which is 3, and 4 plus 3, which is 7. So my angle there is 3 on 7. So that's my step 1, finding this gradient. And now step 2, we'll be substituting it into the equation. So tan theta is equal to 3 on 7. And in order to get, that's not theta, alpha. In order to get alpha by itself, what I need to do is take tan to the other side. And I can do this by taking the inverse. You will need to use your calculator, make sure it's in degrees, and you'll get an answer of 23.2 degrees to one decimal place, as the question has asked. Part B tells us to determine the equation of the line that passes through the point 5 and 2 and at an angle at 45 degrees. So just like we've been doing, we want to highlight all the key points or key words that they're providing us. So the first thing is that we know it's a line. That means it's going to be of the form y equals mx plus c. We know that it's going to go through the point 5, 2, and it has an angle of 45 degrees. Now the two elements of a line is the gradient and the y-intercept. So what we want to be able to do is use that information to find these two elements. So the first thing that I could recognize is that the angle of 45, how that relates is that tan of alpha can give me that gradient. So once I have that gradient, what I can do is substitute in this point to be able to find c. And so here I can see all of my 3 steps that are outlined. Firstly, we find the gradient. We use that to help us find our second point, c, and then I can substitute that all in to give me my final equation. So let's go ahead and complete this. So we've got tan of 45 degrees. That is equal to 1. So you can complete that on your calculator, or this is an angle that you'll become quite familiar with as we go along. So that means I know that my equation is going to be y equals mx plus c, where m in this case is just 1, so I can just write that as x plus c. I then have my 0.5 and 2 that I can substitute in, so when y is 2, x is 5, take that over, we'll get negative 3. And so finally I can write out the equation of the line, which would be x minus 3. The next point that we're going to cover is the midpoint between 2 points. So the midpoint is just that exact point that is a half. So if I just zoom into this diagram, if I've got 2 points here, if we were to draw a line, where would be the halfway point? So as you could imagine, when you are halving something, you are averaging 2 points, and that's exactly what we're going to be doing. So it's x2 minus x1 divided by 2, so averaging the x values, and then we'll be doing the same in terms of averaging the y values. The other formula that we need to know is the distance between 2 points. So the distance is given by this formula, which is x2 minus x1. So that is this distance over here. y2 minus y1 is this distance over here. And when we square it and then take the square root, that'll give us this distance over here. So what I want you to do is just to be able to compare that to the Pythagorean theorem. So the Pythagorean theorem we know as c squared is equal to a squared plus b squared. So we can see that a squared is the distance, or rather a is the distance here, b is the distance here, and that'll help us find c squared. And if we go back to this formula, that's exactly what we've got. This is a squared plus b squared, and then we take the square root to be able to find c, or in this case we're calling it d because of distance. So that's where we get our distance formula from. It is in fact the Pythagorean theorem. So now we're going to go ahead and apply all of this to some points. So given the points negative 3 and 5 and 4 and negative 6, calculate the midpoint between them. So we need to use the midpoint formula. I'm going to label this as x1, y1, x2, y2, and then it's just a matter of substitution. So the midpoint is going to be x1 plus x2, so negative 3 plus 4 divided by 2, and then y1 plus y2, so that'll be 5 plus negative 6 divided by 2. And when we work that out, we'll get a half and negative a half, and that would be the midpoint of those 2 points there. Next, it asks us to calculate the distance between these 2 points. So once again, all we're going to do is use the formula that they provided us with. So that's going to be x2 minus x1 all squared plus y2 minus y1 all squared. Again, we can label our points. So that's x1, y1, x2, y2, and we can go ahead and substitute that in. So x2 minus x1, 4 minus negative 3, plus y2 minus y1, so that'll be negative 6 minus 5 all squared. Negative 4 minus minus 3 is going to be 7, because it's a plus, so that's 7 squared. And then negative 6 minus 5 is negative 11. And then we just need to square those, so 7 squared is 49, 11 squared is 121. And then when I add that together, that's root 170. Of course, if you can simplify that, you would, but in this case, you can't. That is the end of these 2 exercises. This is the homework that you need to complete.